next speaker is Evan Chen from Ooyala, which is a company that does online video content management. I think they had one of the first and largest, biggest Cassandra deployments, and today we will hear how they use Spark on that Cassandra framework, as well as running it as a long-running service. So,
yep. Okay, thank you very much. How are you guys doing today? Yep. Good? Awesome? Awesome. All right. Awesome. How many awesomes do we have? All right. That's more like it. So my name is Evan Chan. I'm a staff engineer at Ooyala. I want to tell you guys about how we use Spark at Ooyala, how we use Spark in Cassandra, but mostly we want to tell you about how we are running Spark as a service with something we call the Spark Job Server. Very quickly, how do we use Spark? Just really quickly, we are a video as a service company. We have some of the biggest media companies in the space, like ESPN, Victoria's Secret. So if you're watching videos on ESPN, you're probably using us. We get about over 2 billion events a day from different people watching video. And we do all kinds of analytics on it. Since the beginning, we've been pretty heavily focused on analytics. In the old days, or sorry, the way that the old workflow, the current workflow works is that someone watches video, we then pipe data through HDFS, and we run giant MapReduce jobs that write to Cassandra. This is fine, but it's not very fast. Takes like 1 hour, 2 hours to do. And we also compute very static aggregates in Cassandra, which is, again, fine, but doesn't allow you to do advanced queries, sort of things. So we wanted to see how we could do better. And what we found, looking around at different technology stacks, we found Spark very compelling for a number of reasons. Among them that it could reduce our latency, as well as allow us the flexibility of offering much more dynamic types of queries over our data sets. So we've become a big Spark user, started investing it at the very beginning of this year. Actually, it was the end of last year. Developers really like it. It has a promise to us of being a unified platform that offers more than just as the replacement for Hadoop, but also, as you see, there's Spark streaming as for both batch and real-time jobs, as well as for machine learning and things like that. We have 2 teams of developers that will probably increase working on Spark stuff. We're actively contributing back to the Spark community, and we have our largest cluster has like over 100 nodes running Mesos. The way that this stack works is that we start off with raw video events. We ingest them into Cassandra. Then we use Spark to create materialized views. Excuse me. And we would use Spark to do predefined queries, and we can also use Spark for running ad hoc queries. And just physically, what we do is that we layer an input format on top of Cassandra to read data out. There's a SerDes that works with Shark. You need a SerDes to work with Hive. And the input format works with Spark. And on top of all that, you have a Spark master, or in Mesos, you have multiple masters. And then we have a job server that answers requests. Now, a job server. Why do you need a job server? First, we envision Spark as a multi-team service that is not just for field developers. We want this to be used by a lot of developers by all of our analytics teams. And what we find is that what every team does is that you set up a bastion box for them. So you need SSH keys for everyone to log in. Then you need to write an app for Spark to create the Spark context. You need to deploy it. You need to monitor the process. You need to track your job status. You need to do some kind of validation. You need a way to kill jobs or cancel them. So there's a lot of common stuff that everyone repeats. And if you've been listening to a lot of the other talks by other companies, you'll find that they're essentially building a service for running jobs that basically everyone is doing something like this to make this process easier. So And lastly, like we have multiple languages, so we want a way to access these jobs in a programmatic way from different languages, right? So what we did was we developed a job server for Spark, which has a REST API. And you can easily operate Spark from any language, any environment. You can run jobs in their own context for like batch jobs, or you can have one Spark context with shared data amongst many jobs. And I'll show you quickly why that's important. It works with standalone mode, with Mesos mode. We haven't run it in Yarn, but I don't see any reason why it wouldn't. And it persists job status and jars so that you can restart it and you can get history information. So the way that this works is that we have a job server. Let's say that you want to run an ad hoc job. This is jobs that might take like minutes or hours or something. And let's say you have a script that can start this job. It makes a call to a REST server. What this does is that this will create a new Spark context for you, and allocates processes on the workers. And this will start the job. And this will return a 202, which indicates that a job is started. Now, what happens is that later on the job finishes, you can then query the job server again for the status, that it's finished or not, and you can get the result asynchronously. Another scenario is that you want to run, let's say, low-latency queries on data that's cached in a Spark context. So this workflow is quite different, and the job server supports this really well as well. But what we do first is that you submit a REST query to create a, I said query context, but it's really a Spark context. So basically, I say I want a new Spark context. For standalone, for example, you say I want this many CPU cores and this much memory per node. And so that's created, but nothing's running in it yet. Now, I'm going to run a job, which is a load data job. This is going to load data from, for example, Cassandra, and this will populate RDDs. Now I can actually run a query job, which is a separate job. It can actually be a separate jar. And this will query the RDD information and return it synchronously via JSON. And I can do this again and again. Here's an example job server job. We have a trait called Spark job. There are two methods that you populate. One is a validate method. And the other method simply runs the job. It's passed a job config. So basically, all the inputs to a job is through a configuration object. Now, the reason why we have a validate is because, especially for a REST API, one pattern we've noticed is that all jobs need to validate the input somehow. You need to validate that, for example, that the date range of a query makes sense and all other kinds of things like that. We don't want to just like run a job and then get some exception because the input isn't correct. We want to return something more useful. So if the validation fails, we will return a 400 to the user so that it's very obvious that this is an input error and not an error in the job. And what you notice that is different in a job server job is that the job does not create a context. The job server does. And the reason why we chose this is because this allows you to, I can run the job in its own context, like an ad hoc job, or it can run it in a predefined context. So it gives you a lot of flexibility in terms of how you want to run a job and if you want to run in different ways. The other thing that the design allows is that, let's say that you want to diagnose your in-memory RDDs, and just being able to see the RDDs in the Spark UI isn't enough. So for example, let's say that I do a post, I will create a new context. I will then run a job that will do something that will say create RDDs in memory. Now let's say I want to diagnose this. I can actually have a diagnostic jar which I can upload to the job server, and then I can run this to get information on my RDD. So it allows you to, it gives you the flexibility of being able to run diagnostics or have basically run any other kind of job to diagnose your data and do things instead of having to have one binary. In fact, you can, let's say that you're developing, you run into, you're doing some calculations. You might not discover the problem until after you do that, and then you can actually submit another job to find out what happened. So an example of submitting and running a job, this is pretty easy. The first curl basically will load a jar to the job server. The second curl will give it an input. This is actually a really simple word count example, the same one that I showed earlier. And this is a synchronous job, meaning that it runs and it waits for the result, and it will return it to you or serialize it as JSON. You could parse it. Another example is just retrieving the job status. So this is something that I can say, let me give me the results of the last two jobs. It shows you how long they've been running, what kind of class they are, and other information like that. Some of the challenges and lessons that we learned. Spark is based around the idea of context, and this is true of the Spark master UI. This is true of the Spark context UI that you see that diagnoses everything. So one thing is that you might have, your notion of a job might depend on what you're doing. So for example, if you're doing queries on a Spark context, then each query could be thought of as a job. Whereas Spark will think of the entire Spark context as an application, right? So the job server is designed around your definition of a job. So it's the notion of a job is a little bit different. And I think that's really useful for us anyway. Now, running multiple Spark contexts in the same process, this is something that we've achieved with the job server. There's a bunch of tricks, though, such as Spark's use of global system properties. There are some ways. One of the things that are coming up in Spark is configuration change that will help solve this problem. Dynamic jar and class loading is tricky. And you need to manage threads very carefully because each Spark context allocates a new thread pool, and so you end up with potentially a lot of threads. Future plans. This says that open source is coming very soon, but I'm happy to announce that as of this very moment, we have actually started the open source process. So you can look at the Spark website and you'll see a pull request for a preview of the job server. It is fully functional. We plan to add JDBC connectors. Today, you can only persist the information job statuses locally or in Cassandra, but you'll be able to do that in the database. And we'll be looking at other goodies such as having an XJ mode and supporting XJ Spark drivers and coordinating restores. Thank you very much. We are hiring. So.
Maybe the next speaker can set up. Let's start you. Okay, so any questions?
Hi, I have a question. Actually, did you guys handle job priorities in the job server?
We haven't handled job priorities yet. That's definitely a good thing to look out for. It might be combined with the Spark's fair scheduler and things like that, which has its own notion of priorities. So,
any other questions?
Do you do anything about deduplication of jobs, maybe? Like if a query gets retried, a job submission gets retried again and again, would it just end up creating multiple contexts with the same data loaded multiple times, or do you do something about it?
That's a good question. Retries, we typically handle retries external to the job server. So I guess our philosophy is we're going to provide the API so that you can implement retries on top. but then we won't do the retry because the semantics of the retry depends on the particular application. Like what works for the query, like I might execute the same query within the same context, but for a different scenario, I might want to kill it and restart it or something. So.
All right, one last question. Have you looked at Tachyon, integrating it with that system? Have you heard of this?
Yeah, we're definitely interested in integrating with Tachyon, although that's kind of application specific. But yes, we are interested in Tachyon.
I thought it can simplify some of this. Essentially, then you could have many Spark contexts lying around, and their state actually, most of the state.
Oh, I see what you mean. Yeah, so it depends on your application. So for our application, Tachyon is not a solution to that because the reason is because even starting up a Spark context on a real cluster could take many seconds, and that's way too long for our application. So,
great. Thanks. Let's thank the speakers.